Hi everyone, hope you have a good day. Here I go with another part of the book High Intermediate 3. As far as I remember, last time we did the exercises related to pages 24 and 25, and we are about to start the reading part today. I'm going to read the text paragraph by paragraphs and then give any explanation that is needed to give a better understanding of the content of each paragraph. Okay, how a machine that can make anything would change everything. Something is going to happen in the next 40 years that will change things, probably more than anything else since we left the caves. So, ironically, James Burke points out the fact that what is going to be created, what is going to be invented in the next 40 years will make the changes in the world that hasn't been made since we started living in the societies and communities, since the time human identified himself. James Burke, as a science historian, author, and TV producer, has a vision for the future. He believes that by the middle of the century, perhaps as early as 2042, our world will be defined by a new device, the nanofabricator. Good. A science historian is someone who studies the history of science. Um, he has a vision for the future. Vision means foresight, anticipation, view for the future. He believes that by the middle of this century, perhaps as early as 2040, our world will be described, will be defined by a new device, by a new tool. What is that device? The nano fabricator. Uh, it, you know, Nano or nano is a prefix which means extremely small. Fabricator is producer, factory. So nano fabricator means a small, tiny factory. What are nanofabricators? They are tiny factories, large at first like early computers, but soon enough you'll be able to buy one that can fit on the desk. You'll pour in some raw materials, perhaps water, air, dirt, and a few powders of rare elements if required, and the nanofabricator will go to work. So, as you might know, the first generation of computers were so bulky, as big as a room, uh, and through the time, now we have computers that you can have in your hand. They are as small as a hand or a brick. Uh, Nanofabricators are going to start with a big size, but little by little they are going to uh, change the size. They will get smaller and smaller that you can have one on your desk. And what you need uh, is raw materials. You'll pour in means you will you will add some raw materials, something like water, air, dirt. Dirt means soil, and a few powders of rare elements, rare substances if required. And then nanofabricator will start working. It sounds like science fiction, although with the advent of 3D printers in recent years, less so than it used to. Eric Drexler, thought by many to be the father of nanotechnology, wrote in the 1990s about molecular assemblers, hypothetical machines capable of manipulating matter and constructing molecules on the nano level with scales of a billionth of a meter. So it sounds like science fiction. At the moment, when we are talking about nanofabricators, it sounds like something imaginary, something fictional. But with the advent of, with the coming of, with the emergence of, with the invention of 3D printers in recent years, uh, nanofabricators sound less science fiction than it used to be. Eric Drexler, who was uh, Eric Drexel, who is thought by many of people to be the father of nanotechnology, wrote in the 1990s about molecular assemblers. Molecular is related to molecules, and assembler is a person or a machine that puts parts of something together. So, what are they? What are molecular assemblers? They are hypothetical machines, imaginary machines that are capable of manipulating matter and constructing molecules on the nano level. They are they are imaginary machines that are able to uh, control, modify, use, operate matter. Matter means substance. Use and control a substance and constructing molecules and producing, making molecules on the nano level, on the level of nano, which is so tiny. What is the size of it? With the scales of a billionth of a meter. The size of them will be a billionth of a meter. In recent years, progress has been progress has been made towards this goal. It may well be that we make faster progress by mimicking the processes of biology where individual cells, optimized by billions of years of evolution, routinely manipulate chemicals and molecules to keep us alive. So, in recent years, the uh, progress has been made toward this goal. You know, we are getting closer to this goal. Uh, it is so probable that we make faster progress by mimicking, by let's say copying, by by imitating uh, the processes of biology, something that happens in the nature, where individual cells, optimized by billions of years, optimized means, if you remember, we studied, uh, improve for more efficiency. So it means that the cells, individual cells that have been improved for more efficiency by billions of years of evolution, through billions of years, these individual cells have been changed, have been the subject of gradual changes and improvements and development, routinely manipulate, very regularly control the chemicals and molecules to keep us alive. But the dream of the nanofabricator is not yet dead. What is perhaps even more astonishing than the idea of having such a device, something that could create anything you want, is the potential consequences it could have for society. Suddenly, all you need is light and raw materials. Starvation ceases to be a problem. After all, what is food? Carbon, hydrogen, nitrogen, phosphorus, sulfur. Nothing that you won't find with some dirt, some air, and maybe a little biomass thrown in for efficiency's sake. So, what is very surprising, uh, more surprising than the idea of having such a tool, such a machine, um, is that uh, you know its potential, its probable results will be so uh, astonishing, will be so surprising. Why? Because suddenly all you need is light and raw materials to produce whatever you want. Suddenly, no, starvation ceases. What is starvation? Starvation is a noun of starve. Starve means to suffer or die because you don't have enough to eat. So starvation means die of hunger. Ceases means to stop something from happening. So starvation ceases to be a problem. Uh, there will be no dying of hunger anymore. Why? Because what is food? Food consists of carbon, hydrogen, nitrogen, phosphorus, sulfur. And all of these things will be found with some dirt, will be produced with some dirt, some air, and maybe a little biomass. Biomass, if you remember, is organic fuel. With a little organic fuel that is added to the material for increasing efficiency. So this machine, if this machine is produced, if this machine is created, the problem of starvation will be gone. Equally, there is no need to worry about not having medicine as long as you have the recipe and a nanofabricator. After all, the same elements listed above could just as easily make insulin, and presumably the superior drugs of the future too. In the same way, similarly, in the same way, there is no need to worry about uh, the lack of medicine. Why? Because we have the recipe, the formula, and a machine to produce, a nanofabricator. After all, the same elements listed above, that is, carbon, hydrogen, and so on, uh, could easily make insulin. You know, insulin is a substance that controls the sugar in your blood. Uh, and presumably and probably, supposedly, we can also use the superior drugs, the predominant drugs of the future as well. What the internet did for information, allowing it to be shared, transmitted, and replicated with ease instantaneously, the nanofabricator would do for physical objects. Energy will be in plentiful supply from the sun. Your Santa Claus magic your Santa Claus magic machine will be able to create new solar panels and batteries to harness and store this energy whenever it needs to. Well, uh, what does the internet do for information? Internet allows information to be shared. We can share information through the internet. we can transmit information, send to each other, and replicate. And we can reproduce, we can duplicate the information with ease. With ease means easily, instantaneously, immediately. The nanofabricator would do the same thing for physical objects. It means physical objects will be shared, transmitted, and replicated easily using nanofabricators. Energy will be in plentiful supply from the sun. So we have abundant energy supply from the sun. Your Santa Claus magic machine will be able to create new solar panels. So our what is Santa Claus magic machine? Our nanofabricators. You know, the writer metaphorically refers to nanofabricators by Santa Claus magic machine. To create new solar panels and batteries to harness, to control and store, save this energy from sun whenever it needs to. Suddenly, only 3 commodities have any value. They're the raw materials for the nanofabricator, many of which, depending on what you want to make, will be plentiful just from the world around you. The nanofabricators themselves, unless of course they can self-replicate, in which case they become just a simple conversion away from raw materials. And finally, the blueprints for the things you want to make. Well, with the advent of nanofabricators, there will be only 3 things that will be valuable, that will be of any value. What are they? The raw materials for the nanofabricators. Many of these raw materials, according to what you need, will be acquirable, will be found in the world around you. So you won't need to buy them. You won't need to suffer getting them. The nanofabricators themselves. So the second commodity that we need is the nanofabricators, unless, of course, they can self-replicate. We won't need the nanofabricators if they can self-replicate, if they can reproduce themselves. In which case, if it happens, they become just a simple conversion away from raw materials. Conversion is noun form of convert, means change. So the nanofabricators, if they produce themselves, they will become nothing but a small, they will become nothing but a change from, that is a bit different from raw materials. So they will become something like raw materials with a small difference. And finally, the blueprints. Blueprints are designs, plans for what we want to make. In a world where material possessions are abundant for everyone, will anyone see any necessity in hoarding these blueprints? Far better for a few designers to tinker and create new things for the joy of it and share them with all. What does profit mean in a world where you can generate anything you want? So, in a world in which material possessions, having materials will be plentiful for everyone. Everyone can have access to materials of any kind. So, will anyone see any will it be necessary to hoard, to store up these plans, these designs, these blueprints? Far better, yeah, it would be better for a few designers to tinker, to manipulate, to modify and create new things. To modify what? To modify these designs and plans and blueprints in order to create new things just for the joy of it, and share them, share those new things with everyone. What does profit mean in a world where you can generate anything you want? So profit, money, wealth, they will become worthless. They will become, unvaluable, because whatever you want, you can produce yourself easily at home. Money will lose its identity, its value, its let's say, its sense. As Burke puts it, this will destroy the current social, economic, and political system because it will become pointless. Every institution, every value system, every aspect of our lives has been governed by scarcity, the problem of distributing a finite amount of stuff. There will be no need for any of the social institutions. In other words, if nanofabricators are ever built, the systems and structure of the world as we know them were built to solve a problem that will no longer exist. Well, according to Burke, this invention, the emergence of nanofabricators, will destroy any present social, economic, and political system, because these systems will be worthless. They won't have any purpose anymore. Why? Because every institution, every organization, every value system, any system that impose value on what we do and what we have, every aspect of our lives has been ruled, has been governed by scarcity. What is a scarcity? Lack. The problem of distributing finite amount of stuff. The materials we have is finite, is limited, and there is a problem of distributing this limited material between the people, among the people, because of mismanagement, because of the governments, the ruling systems cannot manage this fair distribution of stuff. Some people in the world are dying of hunger. Some people have, let's say, infinite wealth, limitless money. It's because the distribution didn't occur accurately, appropriately. So, in other words, if nanofabricators are ever built, if we come up with these nanofabricators, the systems and structures of the world that in the past used to solve the problems won't be will be useless, because there will be no problem to solve. Well, I hope I could make the text that is really difficult more understandable. Okay, part B, decide if the sentences below are true, T, false, F, or not given, and G. Number 1, the new device will be around by 2050. That is true. Number 2, nanofabricators will be tiny from the very beginning. That is false. Number 3, the advent of 3D printers made nanofabricators a reality. That is not given. 4, in recent years, the progress towards nanofabricators has been much faster. That is false. Number 5, people will hoard blueprints instead of other materials. That is false. Number 6, the idea of creating things will affect politics. That is true. Number 7, abundance has always been the source of problems. That is false. And number 8, the structure of societies will change because the problems will disappear. That is true. Part 5C. Answer the following questions. 1. What are nanofabricators? So in paragraph 3, we have the definition of nanofabricators. What are nanofabricators? They are tiny factories, large at first, like early computers, but soon enough you'll be able to buy one that can fit on the desk. You'll pour in some raw materials, perhaps water, air, dirt, and a few powders of rare elements if required, and the nanofabricator will go to work. Question 2. Who is Eric Drexel? Who is Eric Drexler? Sorry. Eric Drexler, thought by many to be the father of nanotechnology. So, Eric Drexler is considered to be the father of nanotechnology. Number 4. How will the problem of food be eradicated? Eradicated means removed, wiped out. So on page 26, the second paragraph from top says the same elements listed above in the first paragraph, I mean carbon, hydrogen, nitrogen, and stuff, could just as easily make insulin and presumably the superior drugs of the future too. Question number Question 3. How are nanofabricators going to be used in the field of medicine? So in the second paragraph on page 26, we see there is no need to worry about not having medicine as long as you have the recipe and a nanofabricator. Okay, the answer is here. The same elements listed above, that refers to the previous paragraph, that is carbon, hydrogen, nitrogen, and stuff, could just as easily make insulin and presumably the superior drugs of the future too. Question 4. How will the problem of food be eradicated? Eradicated means removed, wiped out. So the first paragraph on page 26 says starvation ceases to be a problem. After all, what is food? Carbon, hydrogen, nitrogen, phosphorus, sulfur, nothing that you won't find with some dirt, blah, 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 to the end of the paragraph. So using nanofabricators, we can come up with any sort of food that we want. Question 5. What are the 3 things you will need in the future? The 3 things are the 3 commodities are the raw materials, the nanofabricators, and the blueprints. Number 6. How will nanofabricators change the society? Well, the last paragraph offers the answer for the question. If nanofabricators are ever built, the systems and structures of the world as we know them were built to solve a problem that will no longer exist. Well, that is the end of Unit 2.1. Next time we are going to start uh, Unit 2.2.